Alright, so here we have the harmonic series diverges. This can be found on the Pickover book, page 104. So, a little bit of background is Jacob Bernoulli was the first to publish this proof in 1689 that deals with the harmonic series diverging. Like many other discoveries or ideas, he wasn't actually the first to come up with this idea, even though he might get most of the credit. French philosopher named Nicole Orem was the first to prove the divergence of the harmonic series. However, most of his findings were lost in time. So then a little while later, the Italian mathematician Pietro Mengoli founded it in 1647, and then 40 years later, Johann Bernoulli in 1687. So as you can see, Johann, who was actually Jacob's brother, also proved it, and then 2 years later, Jacob published it. So there might have been some hard feelings about that. So divergent versus convergent. A divergent series is a series of numbers whose limit approaches infinity, so it goes on forever. And then I'll provide an example of that on the next slide. And then a convergent series is when the limit approaches a number such as 0. So it has a stopping point. So an example of the convergent series would be the alternating harmonic series, and that, as you can see here, would be like 1 plus negative 1/2 plus 1/3 plus negative 1/4. And then if you keep going on to infinity, that's going to the limit is going to be 0. And then if you graph that out, you can see as it gets closer and closer to 0. Next, here's the divergent series. So what that is the terms are added together, and then the sum gets closer and closer to infinity. So an example from the Pickover book would be the series 1, 2, 3, 4, and then so on, where if you add the first 4 terms here, you get a sum of 10. But then obviously as you keep adding 5, 6, 7, 8, it's going to get bigger and bigger and bigger. And so if you were to add infinitely many terms, the sum would approach infinity. And then this example explodes, which means it gets bigger very fast. However, here's another example on the left. Kind of same as the other one, but this is the harmonic series, so it's 1 plus 1/2 plus 1/3 plus 1/4, and so on. And then this also approaches infinity, but as you guys can see, that it goes much slower because you're not adding 1, 2, 3, 4, you're adding 1/2. So it's going to get bigger a lot slower. Alright, so more on the divergent series. This is Nicole Orem's proof that, how to prove that he found its limit is 0. So it's pretty, hopefully you guys can get this, but so we need to create a new series where each term is less than or equal to the original term. So to do this, you need to find the largest power of 1/2 that is less than or equal to. So the original term is 1 plus 1/2. So the first 2 terms, what's the largest power of 1/2 that is less than or equal to 1? Well, that's just 1. Same thing for 1/2, less than or equal to 1/2. So then, but when we get to 1/3, what's the largest power of 1/2 that's less than or equal to it? Well, it's 1/2. It's 1/4 because it has to be less than 1/3. So then you would put in 1/4 for the 1/3. What's the power of 1/2 that is less than or equal to 1/4? 1/4. So you drop that in. So then next would be 1/5. Well, what's the power of 1/2 that's less than 1/5? 1/8. So then the next 4 terms would be 1/8, 1/8, 1/8. And as you can see, a cool pattern develops here that as you keep going up, it's going to be just 1 plus 1/2. Add those two, 1/2. Add the 1/8, you get 1/2. Add the 1/16, you get 1/2. So then he realized that that's going to be the pattern forever. So it's going to get to infinity. It's never going to have a limit. And then So if all these are less than or equal to the original equation, or the original series, then the original series is also going to be infinity because it's going to be greater than what you just came up with. So a little bit of digging deeper. I watched a couple of Khan Academy videos to like help explain that, which was really helpful. And here's a more detailed example of it. You can click on that and go watch that video. It's pretty cool. This PDF takes you through the steps of the proof and allows you to see kind of what I explained there a little more in depth. Page 110 of the Pickover book shows the discovery of the series formula for pi, and it's kind of like the same ideas and things that were discussed for this. It's just a little bit like it brings up the alternating harmonic series again. So yeah, looking into that. Here's my photo references and my references. Thank you.
Nice.